Welcome to this Scikit machine learning tutorial. In this session, we will focus on multi-class, multivariable classification using the k-nearest neighbors classifier. Our case study comes from the Android malware dataset, where the goal is to classify applications as either benign or malware based on their permission requests. This slide summarizes the Android malware dataset. Each column represents whether an Android application requests a specific system permission or access to a resource. These include permissions like local access, reading and sending SMS, internet usage, camera and audio recording, and installation privilege. In total, we have over 300 binary encoded features, each indicating whether an app requests that specific permission. Together, these features define the behavior fingerprint of an app. Here, we highlight the dataset structure. The input features are encoded permission flags. Each one indicates the present or absent of a capability requested by the app. The target variable is the malware classification label, 0 for benign cases and 1 for malware cases. The goal of our classifier is to learn patterns from the input features to correctly predict whether a new app belongs to the benign or malware class. This slide introduces the k-nearest neighbor classifier. The k-nearest neighbor is a simple but powerful method. Instead of learning an experience model, it stores all training samples. To classify a new app, it looks at the k most similar apps in the training set based on a distance metric such as hammering or Euclidean distance. The predicted label is the majority class among those labels. This makes KN intuitive, as predictions are driven directly by similarity in permission usage between apps. Finally, we train and evaluate the model. We split the dataset into 80% for training and 20% for testing. This KN has no heavy training step. The focus is on prediction, where distances are computed for each step. We evaluate performance using the F1 score, which balances precision and recall, which is critical in malware detection, where both false positive and false negative carries serious consequences. The workflow is train, predict, and evaluate with the KN classifier. Now let's move on to how to use our Scikit machine learning web app to implement this k-nearest neighbor classification model. First, let's name our project here, and then let's just write a brief description of this project. And then let's choose our data tab as tabular since our data is in CSV format. And then we click upload the CSV button and click attach the file button. And let's choose our CSV file. After successfully uploaded the dataset, we can see the summary of our table. And then in the pre-processing section, let's choose our target label. We have over 300 input features, so this is a very large dataset with very high dimension. Let's choose a label, which is the target label. And then let's choose our classifier. And then let's choose our evaluation metric, F1 score. And then let's click perform. After a few seconds, we can see our evaluation result is 0.92, which is very close to 1, and it tells us our model fits the dataset very well and was able to accurately predict the result. Thanks for watching.